Section 8.3, Testing a Claim about a Mean. Key concept. Testing a claim about a population mean is one of the most important methods presented in this book. This section deals with the very realistic and commonly used case in which the population standard deviation is not known. There is a brief discussion of the procedure used when the population standard deviation is known, which is very rare. Testing claims about a population mean with the population standard deviation not known. The objective. We're going to use a formal hypothesis test to test a claim about a population mean. The notation. N represents the sample size or the number of trials. X bar is the sample mean. Lowercase s is the sample standard deviation. The population mean with a subscript of the x mean, which is this population mean of the sample means, is considered the population mean. What are the requirements? Well, number one, that the sample is a simple random sample. Number two, either or both conditions are satisfied, that the population is normally distributed or that n is greater than 30. Number one, in step one, you want to state the claim and the opposite of the claim. Number two, identify the null and the alternative hypothesis. The null hypothesis is the statement is assumed true until evidence indicates otherwise. The alternative hypothesis is the claim to be tested. Three ways to structure a hypothesis test. You have a two-tailed, a left-tailed, and a right-tailed. So for the null hypothesis, the population mean is going to equal the mean value for all three scenarios. For the two-tailed, the alternative hypothesis is the population mean is not equal to the mean value. For the left-tailed, the alternative hypothesis is the population mean being less than the mean value. And for the right-tailed, the alternative hypothesis is the population mean is greater than the mean value. Now, the alternative hypothesis is the one not containing equality. So the alternative hypothesis uses the following symbols: less than or greater than or not equal to. The null hypothesis is the symbolic expression that the parameter equals the fixed value being considered. Number three, use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. Number four, select the significance level alpha. Based on the seriousness of a type 1 error, make alpha small if the consequences of rejecting a true null hypothesis are severe. The values of 0.05 and 0.01 are very common. Number five, the test statistic for testing a claim about a mean when the population standard deviation is not known. You're using the t-distribution. So t is going to equal the sample mean minus the population mean of the sample means divided by the sample standard deviation, which is divided by the square root of n, which is the sample size. Number six, you're going to find the corresponding p-value or critical value and then draw your curve and then label. So there's two methods, either the p-value method or the critical value method. For the p-value method, in order to get the p-value, we can use technology or use the student t-distribution with degrees of freedom given by n minus 1. And the critical values, you can use technology or the student t-distribution with degrees of freedom given by n minus 1. Then you're going to make a decision. When making a decision for the p-value method, you reject the null hypothesis if the p-value is less than or equal to alpha, and you fail to reject the null hypothesis if the p-value is greater than alpha. For the critical value method, you reject the null if the test statistic is in the critical region, and you fail to reject the null if the test statistic is not in the critical region. And then state your conclusion. If the original claim does not include equality and you reject the null, you would say there is sufficient evidence to support the claim that with the original claim that follows. If the original claim does not include equality and you fail to reject the null, then you would state that there is not sufficient evidence to support the claim followed by the original claim. If the original claim includes equality and you reject the null hypothesis, then you would say there is sufficient evidence to warrant rejection the claim that followed by the original claim. And if the original claim includes equality and you fail to reject the null, then you would state that there is not sufficient evidence to warrant rejection of the claim that followed by the original claim. Okay, the requirement of normality or n is greater than 30. If the original population is not itself normally distributed, we use the condition that n must be greater than 30 for justifying use of the normal distribution. Sample sizes of 15 to 30 are sufficient if the population has a distribution that is not far from normal. In this text, we use the simplified criterion of the following. N is greater than 30 as justification for treating the distribution of sample means as a normal distribution, regardless of how far the distribution departs from a normal distribution. Important properties of the student t-distribution. Number 1, the student t-distribution is different for different sample sizes. Number 2, the student t-distribution has the same general bell shape as the standard normal distribution. Its wider shape reflects the greater variability that is expected when the sample standard deviation of lowercase s is used to estimate the population standard deviation sigma. And number 3, the student t-distribution has a mean of t equals 0. Number 4, the standard deviation of the student t-distribution varies with the sample size and is greater than 1. Number 5, as the sample size n gets larger, the student t-distribution gets closer to the standard normal distribution.